Hello students, welcome to Boundless Maths, your trusted space for both maths and science. In today's video, we are going to cover the salts part of the chapter Acid, Bases and Salts from class 10 CBSE Science curriculum. As you know, to score better in any exam, you need to follow a three-step process. Number 1, understand the content. Number 2, learn the content without missing important details using structured notes. And number 3, practice as many questions as you can as per the format of the paper you are going to appear for. So in this video, I am again going to use my class 10 science notes authored by me specifically to make the NCERT content concise, easy to learn and remember. This is like a companion for your NCERT textbook. You can get a copy of these science notes by visiting my website www.boundlessmaths.com. And if you have not watched the previous video on acids and bases, do watch that video and then continue here for the salts part of this chapter. So let's get started. So we have already seen what are the similarities and differences between acids and bases. What are indicators, what are the different types of indicators, how acids and bases behave with these indicators, classification of acids based on different criteria, then what is the pH scale and what is the importance of pH for humans as well as plants and animals, some commonly used formulas that we are going to use throughout the chapter, and we have already gone through the reactions of acids and bases with metals, carbonates, metal oxides, non-metallic oxides, and all these reactions are already there in the previous video. So just watch this video if you are not clear with any of these things so far. Now in today's video we are going to start with salts. What is a salt? Salt is a compound that is formed when an acid reacts with the base and a salt is formed along with water, right? So if you are given the name of a salt, for example, NaCl. NaCl is the most commonly used salt, sodium chloride. Now by just looking at the name of the salt, can you figure out which acid or which base was used to make this salt? As we know, the names of commonly used acids are HCl, H2SO4, HNO3. So that means if you look at the chloride ion, this probably came from HCl. And Na came from a base NaOH. So that means when you reacted NaOH and HCl, you got NaCl. So this was the base. How do you get the name of the parent base? By adding OH to this cation, and by adding H plus to this anion, you get the name of the parent acid. For example, let's take example of another salt. For example, it is potassium nitrate. Now as you can see, the formula is KNO3. So with the cation, put the OH ion. So that becomes KOH. So that means the parent base is KOH and the parent acid is, with the anion, use H plus ion, so it becomes HNO3. So this is the parent acid. So in the exam you can get a question, identify the parent acid and base for the given salt. For example, it is NH4Cl. Again, with the cation, put OH, ammonium hydroxide. With the anion, put H plus, hydrochloric acid. So you need to understand how to identify the parent acid and base. With the cation, use OH ion, it gives you the name of the base. With the anion, put the H plus ion, it gives you the name of the acid, right? Now the next part of the question normally is, what is the nature of this salt? Identify the parent acid and base and then also tell the nature of the salt. How do you tell the nature of the salt? Now we have done that there are 3 commonly used strong acids, H2SO4, HNO3 and HCl, and these are very strong acids. Strong bases, examples of strong bases are NaOH and KOH, they are very strong bases. So when you mix a strong acid and a strong base, they neutralize the impact of each other and you get a neutral salt whose pH is somewhere around 7. Because the strong acid and strong base, they have neutralized each other. But if you mix a strong acid and a weak base could be something like NH4OH. This is a weak base, ammonium hydroxide. And HCl is a very strong acid. So if you mix a strong acid and a weak base, the nature of the resulting solution will be acidic, because some part of the acid has been neutralized, but still overall nature of the resulting solution is going to be acid. So that means the nature of the salt NH4Cl is going to be acid and it will have a pH of less than 7, right? Let's take example of a weak acid and a strong base. Now NaOH and KOH are the only two strong bases we all understand as of now, right? So NaOH is a strong base and acetic acid is a weak acid. It is an organic acid, CH3COH, this is a weak acid. It will not produce lots of H plus ions even though it will disintegrate in water. So when this weak acid and the strong base, they are combined, what will be the overall impact? It is going to be basic. So that means the salt that is going to get formed here, CH3CONA, it is going to be a basic salt having a pH more than 7. So the pH is more than 7 because the salt is basic now, right? So this table is very important. It is important that you understand how to get the names of the parent acids and bases and how to identify whether the given salt is acidic or basic in nature, right? So let's move forward with some of the important salts, some of the important chemical compounds and their properties, and these are all covered under the salts section of your chapter. So the first salt that we know is common salt, very common name, common salt, it is very common, right? Sodium chloride, the chemical name is sodium chloride. We get this from seawater by evaporation, and we also get sodium chloride from the underground deposits. In the lab, how we can prepare sodium chloride? Again by neutralization reaction of NaOH and HCl, you get NaCl and water. Now this sodium chloride is used as a raw material for making large number of chemicals in the industry, NaOH, Na2CO3, NaHCO3, and it is also used in the manufacture of soap. Yes? So sodium chloride is mainly a cleansing agent. It is used in the manufacture of soap. क्या आपके toothpaste में नमक है? Yes? So you must have heard of it. So why salt is needed in the toothpaste? Why salt is needed in the soap? Because it is a very good cleansing agent, right? So this is how we can remember the use of NaCl, because in this entire table, the entire section of your book, it is very important that you learn the uses of each of these salts or these compounds, because the question is going to be like, identify substance X that is used for example, as an antacid in medicines. So if you identify X clearly, you can answer the question on properties or whatever reactions are being asked further in the same question. So it is very important to understand and learn the uses of all these compounds so that you can answer the questions properly. Next is NaOH. Now the use of NaCl is, it is used in the industry to produce NaOH, Na2CO3, NaHCO3. So from the common salt, you get NaOH. From the common salt, you get NaHCO3. From the common salt, you get Na2CO3. So don't underestimate the power of common salt. It is very powerful. It is used as the basic ingredient, basic reactant that is used to produce NaOH, NaHCO3, Na2CO3, all the next three compounds that we are going to talk about. So the next one is NaOH. NaOH, the common name is caustic soda, and the chemical name is sodium hydroxide. Now how do we get NaOH from salt? We know that solution of salt in water is called brine, and when electricity is passed through this brine, we get NaOH. This process is called chloralkali process, because in this process chlorine is also liberated and NaOH is the base. This base is also created. So this is a very important process, chloralkali process. I'll just show you the setup from the NCERT textbook for the chloralkali process, because this is very important that you understand what is liberated where and how it works. So the chloralkali process is basically used to produce NaOH from sodium chloride. This is the setup given in your NCERT textbook, figure 2.8. Now in this setup, if you can see, hydrogen gas is released at the cathode. Cathode is the negative terminal of the battery, and because H plus ions are positive, how do you learn it? Because H plus ions are positive, they always get attracted towards the negative terminal of the battery. So H plus ions, Na plus ions, because they are positive, they'll move towards cathode. Cathode is the negative terminal of the battery. Hydrogen gas is released, whereas Na combines with hydroxide ions, and you can collect NaOH from the base of the container. So both H2 and NaOH are formed at the cathode end, And what happens at the anode? Because chlorine ions are negatively charged ions, they get attracted towards the anode. Anode of the battery is positive terminal of the battery. So that's why chlorine is liberated at anode, whereas hydrogen is liberated at cathode, and NaOH can be collected from the base of the cathode. Understood? So it's very important for you to learn which component is released where, which component is created where in this chloralkali process. Why it is called chloralkali? Because of the formation of very two useful compounds, chlorine and sodium hydroxide, which is an alkali. So because of the formation of these two things, it is known as chloralkali process. Now let's go back. So here the important components that get released are hydrogen at cathode, chlorine at anode, and NaOH at the cathode base. So the location of all the three is very important. You should remember this. Now where is hydrogen gas used? It is used in the hydrogenation of oil and to make ammonia. What is ammonia? Ammonia is NH3 and ammonium ion is NH4 plus. So please don't get confused between the two. Ammonia is NH3. So it is used to make ammonia for fertilizers. So this is the use of hydrogen gas that is released in the chloralkali process. Now what is the use of chlorine? Chlorine gas is used in water treatment. Those who do swimming, they must be knowing that the swimming pool water is treated with chlorine to keep it infectant free. So chlorine is used for water treatment, clean water in swimming pools, and for making PVC, disinfectants, CFCs and pesticides. Next, NaOH, what we are getting from the base of the cathode base. So it is used in making soap, detergents, paper, artificial fibers and decreasing metals. Again, NaOH is an alkali, it is a base. So that's why soaps are also basic in nature. Soaps are formed using NaOH. Details will go through in the chapter carbon compounds, how soap is formed from NaOH. So we'll have it in detail in that chapter. For now, just remember NaOH is used to make soaps, detergents and paper, and it is also used for degreasing metals. Now why we are doing all these uses and learning all these uses? Because the question will again start from the uses part. Identify X that is used in swimming pools for disinfecting the swimming pools. What is it? Chlorine. It is formed as a byproduct in what reaction? Chloralkali process. Why it is called a chloralkali process? Because chlorine and alkali, NaOH, are the basic products that are formed in this process. So basically when electricity is passed through brine solution, you get NaOH at the base of the cathode, chlorine is liberated at the anode and hydrogen at the cathode, right? So this is how you get NaOH from common salt. Again, don't underestimate common salt. The next thing that we can create from this common salt is baking soda, that is NaHCO3. Sodium hydrogen carbonate. This is a mild, non-corrosive basic salt. So as this says, it is a basic salt. It is created from NaOH, so anyways it has to be basic in nature. So it is sodium hydrogen carbonate. The chemical name is sodium hydrogen carbonate and the common name is baking soda. Have you used baking soda for making cakes? Yes. Yes. It is used to make your cake fluffy and soft and spongy, right? So how do you prepare baking soda first? Again, NaCl. NaCl, the common salt, not very common. The common salt, don't underestimate. NaCl plus ammonia, water and carbon dioxide. NH3, H2O, CO2. When all these are brought together, they react to form NH4Cl and NaHCO3. So this NaHCO3 is baking soda. It has a very important property that on action of heat with baking soda, it releases carbon dioxide, Na2CO3 and water. So this CO2 that is released, it causes the cakes spongy and softer, right? Now this NaHCO3 baking soda is used as antacids in medicines. It is used in soda acid fire extinguishers. It is used in making powder. Now what is the difference between baking soda and baking powder? Baking powder is actually a mixture of this baking soda with a mild edible acid, for example tartaric acid. It could be any mild acid plus baking soda gives you baking powder. Now how baking powder works? On heating this baking powder, again CO2 is released that makes your cake spongy and soft, along with the formation of sodium salt of the acid. Whichever acid, mild acid has been added, so sodium salt of that acid is formed and CO2 is released. So this is how baking powder is different from baking soda. Baking soda is NaHCO3, but baking powder is a mixture of baking soda and a mild edible acid. So if you are asked the difference between baking soda and baking powder, you should know now, right? Next compound here is washing soda. What is washing soda? Na2CO3 dot 10H2O. 10H2O means it has some water of crystallization. So we'll see what is water of crystallization. Now the chemical name is hydrated sodium carbonate. It is not just sodium carbonate but hydrated sodium carbonate. Sodium carbonate is what we got here in this reaction also. In the previous reaction, when we heat baking soda, we get sodium carbonate. But can we call this as washing soda? No. You have to hydrate it further to create washing soda. So washing soda is hydrated sodium carbonate. This sodium carbonate, when this is hydrated, you get washing soda. So Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. So the first step is heating of baking soda to give Na2CO3, and Na2CO3, when it is hydrated using water, it gives you washing soda. So basically all these are formed using common salt. Don't underestimate common salt again. So the uses of washing soda. What are the uses? It is used in glass, soap and paper industry. It is used in the manufacture of sodium compounds such as borax. This is very important. And it is used to remove permanent hardness of water. Again, this is very important. Which substance is used for removing permanent hardness of water? The question might start from there. So it is very important that you understand washing soda is used to remove permanent hardness of water. It is also used as a cleaning agent for domestic purposes. As the name tells you, washing soda is used for cleaning and washing purposes. So which substance, which compound is used to remove permanent hardness of water? Washing soda. Which compound is used for baking cakes? Baking soda. These are the common names. You should know baking soda is sodium hydrogen carbonate. Washing soda is hydrated sodium carbonate. I hope it's clear. Now the next compound here is bleaching powder. Why we are talking of bleaching powder here? We were talking of salts. Now what is this bleaching powder and from where it came here? Its chemical name is calcium oxychloride. CaOCl2. I already told you, you should know the formula of bleaching powder, very important from this chapter. Now how is CaOCl2 formed? The chlorine that you get in the chloralkali process. Here you have chlorine. This chlorine, when it is passed through dry slaked lime. So this is dry slaked lime, and when you pass this chlorine through dry slaked lime, you get bleaching powder CaOCl2. So indirectly this is also formed from NaCl. From NaCl you created NaOH by chloralkali process, and another component of this process was Cl2, and using this Cl2 you created bleaching powder by making this Cl2 pass through dry slaked lime. So indirectly NaCl is used to make bleaching powder also, even though there is no Na here. So all these are interrelated, and this is how you can learn them. Dry slaked lime, when chlorine is passed through it, you get calcium oxychloride, which is bleaching powder. What is the property? As the name tells you, bleaching powder. Bleaching powder is for bleaching wood pulp. It is used for bleaching cotton and linen in textile industry. So it is used as an oxidizing agent in chemical industries. Disinfectant for water. So this has a very important property that bleaching powder, for example, if you add bleaching powder to H2SO4, you get CaSO4, chlorine and water. Chlorine produced by the action of dilute acids. Now this dilute acid with bleaching powder, this acts as bleaching agent. So what is actually causing that bleaching property of bleaching powder is chlorine. So chlorine, how it is chlorine is separated from this formula CaOCl2. How do you separate chlorine? By adding a mild acid, dilute acid, not mild, you should say dilute acid, very dilute acid. H2SO4 is not mild, it is a strong acid, but you use a very dilute acid here. So CaOCl2 plus H2SO4 gives CaSO4, chlorine and water. So whenever any kind of bleaching is to be done, a very dilute acid is also added to the bleaching powder so that this chlorine gets liberated, and this chlorine is responsible for the bleaching property of bleaching powder, right? Next is plaster of Paris. Now from bleaching powder we got CaSO4. So what is plaster of Paris? CaSO4 dot half H2O. Half is hemi. So hemihydrated calcium sulfate. So calcium sulfate hemihydrate is the chemical name for plaster of Paris. Plaster of Paris is the common name. Calcium sulfate hemihydrate is the chemical name of plaster of Paris. CaSO4 dot half H2O. This does not mean that half molecule of water is attached to CaSO4, but this means two molecules of CaSO4, they share just one molecule of water. Right? Understood? So now what happens to this CaSO4.2H2O? This is called gypsum. What is CaSO4.2H2O? This is called gypsum. Gypsum is little different from plaster of Paris. Let's see what is the difference between them. When gypsum is heated to 100 degrees Celsius, because one molecule has two molecules of water, so some of this water will get evaporated, some of this water will move out, and you will get calcium sulfate with half molecule of water. That means two molecules of calcium sulfate with only one molecule of water attached to them, and now it is called plaster of Paris. So how do you form plaster of Paris? By heating gypsum. Gypsum is CaSO4.2H2O. Please remember, gypsum is CaSO4.2H2O. Plaster of Paris is CaSO4.half H2O. If the question says what is the difference in the water of crystallization of gypsum and plaster of Paris, what is the difference? Definitely you will explain that gypsum has 2 H2O and plaster of Paris has half. But the question says what is the difference in the water of crystallization? So 2 minus half is 3 by 2. 3 by 2 molecule of water which actually gets lost when you heat gypsum. So the difference is 3 by 2 molecule of water, but definitely you will explain that gypsum has 2 molecules of water and CaSO4 has half molecule. So the difference between them is 3 by 2 molecule of water. Clear? Now heating gypsum to a temperature above 100 degrees Celsius, it will eliminate and anhydrous CaSO4 will be obtained, because when we are heating, water is getting lost. It still needs half H2O, and if this half is also gone, all the water is gone, then it becomes anhydrous CaSO4, which is useless, and it is called dead burnt plaster. So now this dead burnt plaster is useless, right? Now CaSO4.half H2O, again it means 2 molecules of CaSO4 sharing 1 molecule of water. Now there is a very important property of plaster of Paris. What is that property? If you add water to it, it sets into a hard mass, gypsum is again formed. So from gypsum you created plaster of Paris by heating, and in plaster of Paris if you add water, it will again get more water of hydration and it will get converted to gypsum, which is a hard solid. So this is used for setting fractured bones. If any of you has gone through that unpleasant experience of a fracture, so this the bandage that is put around that broken bone, it is made up of using that fabric bandage and white powder that becomes very hard when it is mixed with water. So it sets down very quickly. So it sets into a hard mass on wetting with water, and this is hard mass, this is actually gypsum. So this was created because of the reverse of this reaction. You can say plaster of Paris was hydrated to create gypsum here now. So CaSO4.half H2O plus 1.5 molecules of water gives CaSO4.2H2O. Gypsum that sets as a hard mass for curing plaster, for setting the bones, fractured bones, right? So therefore, you know what, POP, plaster of Paris, this should be stored in moisture proof containers, so that even if it captures moisture from the atmosphere, it will become hard and that will make it useless. So POP has to be stored in airtight containers, moisture proof containers, to let it be the way it is. So what are the uses of POP? It is used in hospitals for setting fractured bones to ensure correct healing. It is used in making toys, decorative materials, clean, cheap ornaments and casts of statues. And it is also used as fireproofing material. Right, so that's it about all the salts that are there in your syllabus. So when you are doing revision of salts, please remember to focus on the uses of all these salts. The entire set of questions for salts normally starts from the uses, then it comes to properties, then it also goes to how they were prepared and what are the different properties and how they are used and whatever. So please learn the uses, especially the important ones. What is used to remove permanent hardness of water, what is used as an antacid in medicines, what is used for making soaps, detergents, papers and artificial fibers, then disinfectant in swimming pools, chlorine, and then manufacture of soap. It can be NaCl also and it can be caustic soda also, right? So read the question very carefully, understand what is being asked, what properties are being talked about, what are the formation steps. Learn all these reactions and always write balanced chemical equations. Now the last topic of salts is water of crystallization. What is water of crystallization? We have already seen water of crystallization in some compounds. So it is the fixed number of water molecules present in one formula unit of a salt. For example, hydrated copper sulfate. What is copper sulfate? You must have seen copper sulfate crystals in the lab in your schools also. There are blue colored crystals and if you put them in water, they give you blue color water. So these copper sulfate crystals, they have 5 molecules of water attached to every molecule of CuSO4, right? So it is blue in color till it is in the crystallized form, and if you heat this copper sulfate crystals, if you directly heat them, they will lose all their water of crystallization and CuSO4, which is white in color, will be obtained because all the water has gone now. So CuSO4 has how many molecules? How much water of hydration? It is 5 molecules of water. Washing soda, we have already seen it has 10 molecules of water, and gypsum has 2 molecules of water. Plaster of Paris has half molecule of water. Basically 2 molecules of CaSO4 sharing just 1 molecule of water. So this is water of crystallization. All the 3 examples given here are very important, especially CuSO4. It has 5 molecules of water as the water of crystallization. So all this can be there in the form of assertion, reason or MCQ. So you should know all these minor details. So hope you liked the video. It was useful to do a recap of the entire topic of salts from acid, bases and salts. If you like the video, do share the video with your friends, and if you still do not have your copy of science notes, order it now from the website www.boundlessmaths.com. So share the video with your friends so that they can also benefit out of it, and do subscribe to Boundless Maths. Till then, keep learning, keep growing. Thank you.